Welcome. From nuclear physics, we are discussing about the nuclear force. In previous lecture, we discussed about the different elementary particle such as lepton, then meson, hadrons, then baryons. So these are the different elementary particles. Friends, in this lecture, we have to see what is Quark model. We know that the leptons are the true elementary particle. These leptons does not have measurable size. It does not have internal structure, and therefore the leptons cannot be break into the constituent particles. While hadrons are the complex nature or complex particle, these complex particle, that is hadron, have definite size or measurable size, internal structure, and the hadrons can be break into the constituent particle or constituents, and these constituents are called as a quark. The hadrons break into the constituent particle known as a quark. There are generally three constituent particles of hadrons, or there are three types of a quark. First is U quark, second D quark, and third is a S quark. This quark also have its anti-quark, that is anti-quark U, or simply we can represent bar U bar, then anti-quark D, anti-quark S. Now this quark have different charge. Okay, quark have the different spin or simply isospin and strangeness. So first, if we consider U quark, then this U quark have a charge plus 2/3 e. This is charge of U quark, okay, plus 2/3 e. Its isospin or simply spin is plus half. So it is spin in upward direction or up spin. Okay. Then its strangeness is 0. Second quark is D quark. The charge on a D quark is minus 1/3 e. Then isospin of the D quark is minus 1/2, or spin of this D quark is minus 1/2, so it have the down spin like this. Okay, and the strangeness of a D quark is a 0. Then the S quark. S quark have a charge minus 1/3 into e. If we observe this, then we noted that the charge on D quark and charge on S quark is the same. It is minus 1/3 into e. Then the spin of a S quark is half. So it is a side spin. Then the strangeness of S quark is -1. Okay. So this is related to U quark, D quark and S quark. The baryon number for all these quark is +1/3. Okay. Baryon number for all these quark, that is a U quark, D quark and S quark, is 1/3. Now, if we consider the anti-quark, that is U bar, D bar, S bar, then the charge on anti-quark U is -2/3 into E. Okay. Then isospin of this anti-quark U is -1/2. Okay. Then similarly for D quark, anti-D quark have a charge +1/3 into E. Okay. Spin is a +1/2. Then the anti-S quark have a charge +1/3 into E, and the spin or isospin is -1/2. Now we have to see the different elementary particles. Okay. So these are the different hadrons. This is mesons. That is a pi plus meson. These represent kaons. Then this is proton. This is neutron. And this is omega. And it's an antiparticle. Okay. Now, if we consider the pions or pi mesons, then it consists of the quark U or U quark and anti-quark of a D. Okay. Anti-quark of a D. So here, if we consider the pi plus mesons, okay, so it consists of a quark U and anti-quark of a D. Okay. So we can represent it like this. Okay. Here is a U quark. Charge on a U quark is +2/3 into E. Okay. Second is anti-quark, anti-D quark. Okay. So this can be represented like this. Okay. The charge on a D quark is -1/3 into E. So charge on its anti-quark is +1/3 into E. This represents pi meson. Okay. This represents pi meson. Now, if we consider pi minus or its antiparticle, pi minus mesons, then it can be represented like this. Okay. Again, so pi minus, so it is made up from anti-quark of a U and D quark. Okay, that is, this represent its constituent particles are U into D bar. So pi minus mesons, its quark content is U bar into D. Okay. Now charge we can represent like this. Okay. U bar charge on the U bar is 2 by 3 into E. So anti U bar have a charge minus 2 by 3 into E. And second D quark have a charge minus 1 by 3 into E. So this is related to the pi mesons strangeness. So first hadron is pi meson. Pi plus meson. Now the baryon number for U quark is 1 by 3. Baryon number for a D quark is 1 by 3. But the baryon number for anti quark, D quark, is minus 1 by 3. So baryon number for pi meson is a 0. Now charge on pi meson, we know that charge on the U quark is 2 by 3 E. Charge on a D quark is minus 1 by 3 into E. But the charge on anti-D quark is plus 1 by 3 into E. So plus 1 by 3. Here E is represented here, common. So it is equal to 3 upon 3. So it is equal to 1. Charge on the pi meson is 1, or that is E, plus E. Okay. Similarly, the charge on the negative meson, pi meson, is a minus E. Now spin. Here, the spin of U quark is half spin. Okay. Now spin of a D quark. Spin of a D quark is minus half. Okay. Spin of D quark is a minus half. Spin of a D quark and its anti-D quark is the same. So it is a minus half. So it is equal to 0. Now strangeness. The U quark have strangeness 0 plus D quark and its anti-quark have strangeness 0. So it is equal to 0 plus 0. It is equal to 0. Now second particle is chaos. Okay. This chaos contains the U quark and anti-S quark. So baryon number is 1 by 3 minus 1 by 3. Baryon number for U quark, baryon number for U quark, D quark and S quark is 1 by 3. Baryon number for anti-quark, that is a U quark, D quark and S quark. Anti-U quark, D quark and S quark, it is equal to minus 1 by 3. So it is equal to 0. Now charge on chaos is charge on a U quark is a 2 by 3 into E. Charge on a S quark is minus 1 by 3 into E. Okay, but we consider anti-quark, anti-S quark. So it is a plus 1 by 3 into E. So it is equal to 1. Okay. So charge on the chaos is 1, or simply plus E. Okay. Now spin. Spin of a U quark is plus half. Spin of S quark is 1/2. But of anti-quark of S is minus half, so it is equal to 0. Now strangeness for U quark is 0 and strangeness for anti-quark of S is strangeness for anti-quark of S. Strangeness for S quark is minus 1 and strangeness for anti-S quark is 1. So it is equal to 1. Now we have to consider next hadron, that is a proton. Proton is made up from or the constituent quark are 2 U quark and 1 D quark. So that we can represent proton like this. This is a U quark which have charge 2 by 3 E. Second U quark have charge plus 2 by 3 into E. Okay. And third D quark which have charge minus 1 by 3 into E. So this represents proton. This represents proton, which consists of 2 U quark and 1 D quark. Okay. Now we have to find the baryon number. Baryon number for U quark is 1 by 3. Baryon number for second U quark is 1 by 3. And baryon number for the D quark is also 1 by 3. So this is 3 by 3. So it is equal to 1. Baryon number for proton is 1. Now we have to find the charge on the proton. Here charge on a U quark is a 2 by 3. Charge on second U quark is a 2 by 3. And charge on a D quark is minus 1 by 3. Okay? 1 by 3 into E. 2 by 3 into E. 2 by 3 into E. Minus 1 by 3 into E. So it is equal to 4. 4 by 3 minus 1 by 3. So it is equal to 3 by 3. And so 3 by 3 it is equal to 1. Or simply we can say that this is a plus E. Charge on a proton is a plus E, which is a positive charge. Here we can represent it is E or simply plus E. This is also true. Okay. Now we have to find the spin of a proton. For that, the spin of a U quark is plus half. Spin of second U quark is again plus half. And spin of a D quark is minus half. And therefore, the proton have a spin, half spin, which is a plus half spin. Okay. Now we have to find the strangeness of a proton. Proton U quark have strangeness 0. Second U quark have strangeness 0, 0 plus 0. And the D quark have strangeness 0. So 0 plus 0 plus 0 it is equal to 0. So this is related to proton. Baryon number is 1. Charge on proton is plus E. The spin of a proton is plus half and the strangeness is 0. Now we have to consider next hadron is a neutron. Okay. The neutron have the constituent quark, that is U quark and 2 d quark. So we can represent neutron like this. Okay, the neutron have one u quark. U quark have charge 2 by 3 into E. Okay, 2 d quark. So d quark have charge minus 1 by 3 into E, and second d quark have charge minus 1 by 3 into E. So this is neutron. Okay, now we have to find the baryon number for neutron. The baryon number for u quark is 1 by 3. Baryon number for d quark is 1 by 3, so plus 1 by 3. Baryon number for second d quark is again 1 by 3, so it is equal to 3 by 3, so it is equal to 1. Baryon number for a neutron is 1. Now we have to find the charge on a neutron. Here, the charge on a u quark is a 2 by 3 into E. Charge on a d quark is minus 1 by 3 into E, and charge on second d quark is minus 1 by 3 into E. So it is equal to 2 by 3 minus 2 by 3. So it is equal to 0. That is, there is no charge on neutron, or charge neutron are neutral. Okay, so charge is equal to 0. Now we have to find the spin of a neutron. Spin of a u quark is half spin. Spin of d quark is minus half, and spin of a second d quark is a minus half. So it is equal to half minus 2 by 2. Okay, so it is equal to minus half. Okay, minus half. This is the spin of a neutron. Neutron have down spin. Okay, proton have up spin, while the neutron have the down spin. Okay, so it is a minus half. Now we have to find the strangeness of a neutron. Neutron, u quark have strangeness 0, d quark have strangeness 0, and second d quark have strangeness 0. So 0 plus 0 plus 0, it is equal to 0. So the neutron have 0 strangeness. Now second, the last hadron is omega, and it's antiparticle. Omega and it's antiparticle, which is made up from 3 s quark. Okay, so baryon number for this s quark is 1 by 3, second s quark 1 by 3, third s quark 1 by 3, so it is equal to 3 by 3, it is equal to 1. Baryon number for omega, antiparticle of omega, is 1. Now charge on s quark is minus 1 by 3. Charge on second s quark is minus 1 by 3. Charge on third s quark is a minus 1 by 3. Okay, so this is equal to minus 2 by 3 minus 1 by 3. So it is equal to minus 3 by 3. So it is equal to minus 1, or negative charge is on omega, okay, minus 1. Now spin of the S quark is plus half. Second S quark have a spin plus half, and third S quark also have a spin plus 1/2. So it is equal to 3/2. This is spin of 3/2 E. Okay, 3/2. This is the spin of the omega particle. Okay. Now the strangeness of this omega particle is strangeness of S quark is -1. Second S quark has strangeness -1. Third -1. So it is equal to this is -2 -2. So it is equal to -3. This is the strangeness of the omega particle. Okay. So this is related to Quark model. The quark, we know that the leptons are two elementary particles which no measurable size, internal structure, do not break into small constituent, while the hadrons are complex one which have definite size. It have the internal structure and can be break into the constituent, and this constituent is known as the quark. There are generally three quark: U quark, D quark and S quark, and its anti-quark, that is U bar, the D bar and S bar. Now the charge on U quark is a plus 1/3 into E. Spin of a U quark is plus half. Strangeness is 0. D quark have charge minus 1/3 into E. Then its spin is minus half and strangeness is 0. While the S quark have a charge minus 1/3 into E, and its spin or isospin is half and strangeness is minus 1. Then we discuss the different hadrons, that is the pions or pi mesons, then kaons, protons, neutrons and omega particle, antiparticles. Then this quark content of a pi meson is a U quark and antiquark of a D. This kaons contain U quark and antiquark of S. Proton contain 2 U quark and 1 D quark. Neutron contain 1 U quark and 2 D quark, and the omega contain 3 S quark. Then we find the baryon number, charge and spin, charge, spin and strangeness of these all hadrons. Thank you.